Hey everybody, how you doing? This is Tom Balator, this time with a walkthrough for problems 1, 2, and 3 in pset 3. I put these three together in a single walkthrough because I believe not only is the code very short, but it's also very related. You'll be able to see that you can reuse most of what you've done in each of those problems in following problems. So let's take a look here first at problem number 1. Is the word guessed? I assume that you've already read through the introduction, that you've read through the whole specification. That's very important. And you know that we're supposed to be writing a function here called isWordGuessed that takes in two parameters. A string called secretWord. That's going to be chosen by a random method in the program we'll be looking at in a second. And letters guessed. These are the letters that the user has guessed. And we'll talk about that too. Basically, if all of the letters in secretWord are in letters guessed, the user has guessed the word, and you want to return true. The word is guessed. If that hasn't happened yet, if there's a letter in secretWord that isn't in the letters guessed, that means you haven't guessed the word yet, and you return false. Okay, let's take a look at this in the text editor I was showing you earlier in the previous walkthrough called Atom. I like this because it's able to collapse down these functions into sort of an outline view. And what we're going to be doing here is simply writing this function. I find it easier to work through these if I can see digestible chunks that I can deal with. And this is what we're doing right here. Basically, secret word is coming in, and that's a string, the word the user is guessing. But where does that actually come from, secret word? If you look through the code, and let me collapse this down again, you'll see at the very end here in a comments section, there is a place where you're supposed to be uncommenting this line once you're done coding the whole program. And there will be a variable called secret word, which will get the value of a function, the return value of a function called chooseWord, which is being called with the parameter of wordless and then set to lower. So all the characters in the word will be returned as lowercase characters. So where is chooseWord in this program? If we look up here to the helper code, inside helper code there's a function already that exists called chooseWord, called on wordlist. And what it does is it uses the random module, called a method called choice, on wordlist. But where exactly does wordlist come from? If you look down here, there's a variable also slightly outside the helper section. Wordlist is getting the return value of a function called loadWords. So where's loadWords come from? This gets a little confusing, but it's pretty cool. There's another function up here called loadWords. And loadWords, basically it's going to be opening the file called words.txt that we've put in the same folder. It's going to be reading that file, it's going to be splitting it along lines, and it will be returning a list called wordList. So basically, it's going to take that file and make a list of all the individual words in our words.txt. Really nice little helper code. You can actually probably write this on your own as a challenge for once you've finished this problem set if you're looking for a little work to do before the test. Okay, so that's what we've got. It's coming into here, these two different parameters. Secret word is fine. Letters guessed, though, where is this coming from? It's a list of what letters have been guessed so far. Logically, that can only come from the user. And that's going to be something that you're going to be implementing in Hangman down here. We don't have any code for this yet. And at this point, that's okay. You're making these first functions, but you're knowing and you're remembering that later on, you will somehow be making a list of the letters guessed. And that's the way you go about making these larger programs. So you just assume it's going to be there. Now, if all the letters of secret word are in letters guessed, then you return true. If not, return false. So let's go over to the IDE and do a little pseudocode here. So if all of the letters in letters guessed, if all of the letters are in secret word, then return true. So what does that mean? We have to walk down all of the letters in secret word. So for all the letters in secret word, what do we want to say? If they're in letters guessed, then say okay. That's possible, but I think it seems more likely, or a little bit shorter perhaps, to say that, hold on. If there's a letter that's in the secret word, but is not in letters guessed, that means that the user has not yet guessed that letter, and therefore they have not yet guessed the word. So we can look for something a little bit different here, perhaps. If the letter is not in letters guessed, then, you just want to stop right there. Stop right now and return false, because you know the word has not been guessed. They're missing at least one letter. Now, if you go through this whole for loop and you check each letter in secret word, and this condition of there not being in letters guessed doesn't happen, that means they are all in letters guessed, then guess what? You've guessed the word, so you want to return true. And that's all there is to problem number 1. Okay, let's go on to problem number 2. Let's see what the specification says for that. If you look at problem number 2, it says printing out the user's guess. What we want to do is create a function called getGuessedWord, which takes in the secret word and the letters guessed, and then returns something like this. If the secret word is apple, and if the user has already guessed, let's say, E and P, which are in apple, but they have not yet guessed A and L, we want to return a string that looks like this, where the A and the L are just simply underscores. This is really nice for the user experience, and it helps you guess the word. But this is something we have to do. So let's take a look at the collapsed program here. Right now, in problem number 1, you've already finished this part of is word guessed. This should be filled in with nice code here. Moving on to the second one here, get guessed word. We've got the same inputs. We need to fill in this code. And I think the code itself is actually really, really similar in terms of pseudocode to what we had before with a few tweaks. So let's look at this pseudocode that we had before. So for all letters in secret word, I guess what I should really say is for each letter in secret word. So we're going to walk down secret word. And if we're walking down secret word, remembering, let's say apple, A, P, P, L, E. As you walk down those letters, you're going to check if that letter is in letters guessed or not. And simply, if the letter is in letters guessed, then you want to somehow, print out that letter. And when I say print, we're not going to print, but just keep that in mind. You're going to somehow make a note of that letter right there. And if it's not, let me take that off. Otherwise, you're going to want to print out a space, an underscore, excuse me. You want to print out an underscore with a space, perhaps. So you can think of this in terms of a string. That's just an underscore with a space following it. And when you're done with that, you somehow want to return to the user a string as per the specification. Return, that string that you've just made. One of the key insights that you're going to have here is figuring out a way of literally creating and making a new string that's going to become that blank or underscore P underscore E in the case of the apple example we just saw. So you've done this before in, I think it was pset 1, where we just made an empty string, and we can call it anything you want, maybe call it word. There's your empty string. And you're going to be doing something on that empty string right here. You want to perhaps concatenate the letter onto word. And otherwise, you want to maybe concatenate an underscore and a space onto word. And then you want to return the word. And that'll get you through problem number 2. Okay, let's move on to problem 3, the last one in this walkthrough. And I think you'll find this one a really nice, easy piece of code to write, and it should give you some confidence about how much you've made towards solving this problem set, and also how far you've made it in this course. Let's take a look at the specification itself. If you look at problem number 3, what does it say here? Printing out all available characters. We're going to have to implement a function, get available letters. It's going to take one parameter, which is letters guessed, and then we're going to return a string of the letters that are not in letters guessed. Really simple stuff. We're going to start with 26 letters. It may either be a string of 26 letters or a list containing those 26 letters. That depends on how you wish to implement it. Nevertheless, we've got A through Z when we start the game, and then the user will be making guesses as he or she goes along. What we need to do is remove those guesses from that string or from that list. That's it. And then return the smaller list of the ones that have not yet been guessed. Before we do that, inside the specification, there's this interesting hint here about using something called string.ascii_lowercase. Now, when you see this, you might be wondering, why would you use this? It's something in Python that will give you the string A through Z, the 26 letters A through Z. Now, you could type that in, right? I think the thing is, if you type things in, maybe you make a mistake. If you use this, odds are that mistake will not happen. Therefore, this is one way of abstracting out and giving the burden to something else that has been tested to be shown to give A through Z, instead of doing it yourself. So let's use this idea of importing module string and then calling this string.ascii lowercase and assigning that, binding that to a variable that we'll call something. So let's look at the pseudocode itself. We've got, well, I'm going to delete this because that was from the previous one. What are we trying to do in terms of pseudocode here? Well, first of all, we want to get that list of the alphabet. What was that? Import string. That was one thing we had to do. And then we want to bind that to a variable. So let's make something called, alphabet perhaps, and then give it that value of, what was it? String.ascii lowercase. And that will bind the value of that string.ascii lowercase to alphabet. So alphabet will be a string from A to Z. And then we need to do some things. And this is where it's really, really simple. All you have to do is, for any letter in letters guessed, you want to remove that letter from alphabet, or whatever you're calling it. Maybe instead of alphabet, remaining letters or something that like that might be a better title. Once you do this, you just want to report that result to who called you. In terms of function, you want to return it, right? So the only tricky part here is to figure out how you're going to remove a letter from either a string or from a list. So a few hints here. If you're looking at strings, we've seen this discussed in lectures, and also there's this really nice website, the docs.python.org, that contains a lot of information about methods available on strings. One of them that you might find interesting and useful here is replace, in which you would be able to replace a given element of a string with another something. In this case, you're trying to remove it, so maybe replace it with nothing. That would remove the letter from the string. And remember, the trouble with strings, though, is they're not mutable. So when you do this, you're actually going to create a new string that is going to be missing whatever you've taken out. If you want to be more efficient about this, you might want to use a list. And that's, in the long term, what I recommend everyone does. If you think about lists, there was this really nice slide in the lecture on lists in two different things that might be useful here. One is how to actually make a list. Let's say we've got that string from A to Z. How do you convert that into a list? Well, Python is great. It's got this really nice command, list. So you could just say list alphabet and bind that to something, a list that you just made. And then you can do your work on that list, somehow removing or replacing or whatever the syntax is here. I leave that for you. How to remove something out of a list. We've seen that. And then what you need to do at the end there is, because we're going to be returning a string from this function, we need to take that list and move it, make it back into a string. And the way of doing that is simply this command right here. So the tools are at your disposal. When you're done with that, you will have finished these three functions. You will have gotten green check marks, and you will be ready to deal with Hangman, which is almost ready to be solved. So see you in that walkthrough. Bye-bye.